webcast continues worksheet 2B, and I'm looking at the last two problems, number 6 and 7. So we're looking at these examples. These were the first two examples we looked at in this worksheet, but by this point we have talked about definitions for displacement and distance and how they are different, and also for velocity and speed. And so I want to take each of these scenarios and just analyze them to find displacement and path length, and average velocity for the whole trip, and average speed for the whole trip. Okay, so in the first situation here, we have a position versus time graph. It shows an object moving at a fast speed in the positive direction, pausing, and then moving at a slower speed in the negative direction. So the total displacement for the entire trip, remember that the formula for displacement is delta x equals the final position minus the initial position. In this particular case, the object ends up at position 0 meters. I can see that right here. And it started out at position 0 meters, right? At time 0, it was at position 0. And so it ends up in the same place that it started. So in this case, the displacement was 0 meters. Now, let's look at the path length. Now, path length, which is also called distance, is the entire path length that the object moved, counting every step and ignoring the direction. So each step that's made, I'm considering that it's in the positive direction. So what I want to do, this is D, I want to take the sum of the absolute value of the individual displacements. And so for the first part of the trip, which I'll call A, the displacement was 4 minus 0, right? In that first part of the trip, it moved from position 0 to position 4. And then I want to add the absolute value for the second part of the trip, which was I'm labeling B up here. It ended at 4 and it started at 4. And then I want to add the absolute value of the displacement for part C of the trip. In the last part of this trip, when it's moving in a negative direction, it ends at a position of 0, but it began at a position of 4. So when I add these up, I have 4, it moved 4 meters in the positive direction, then it paused, so that was 0 meters in the middle, and then it moved 4 meters back in the negative direction. So the total distance moved was 8 meters. Okay, now that I know how far this object went, both in the sense of displacement, which is how far it moved from where it started, and in terms of the path length, I can find both the velocity and the speed. The average velocity for the whole trip is the total displacement divided by the total time. Well, we calculated the displacement. It was 0 meters because this object ends up where it started. But it moved for 7 seconds. But anyway, 0 divided by 7 is still 0. So the average velocity here for the whole trip was 0 meters per second. And then the speed is the distance divided by the elapsed time. And this object moved a total distance or path length of 8 meters in 7 seconds. And so that would be 1.125 meters per second was the average speed. Let's do one more of these for the second example. And here they gave me a motion map. And again, displacement of this object is its final position minus its initial position. I can see at the end it's at a position of 4 meters. The beginning, it was at a position of 5. So the displacement here is -1 meters. The path length is going to be the sum of the absolute values of the displacements for each part of the trip. So the first part of the trip, this object moved in the negative direction from 5 meters to 2 meters. So it moved 3 meters in the negative direction. So the displacement was -3, but I'm going to take the absolute value of it. Then it paused, so I can just say 0. And in the next phase of the trip, it was displaced from 2 meters to 0 meters. So it moved 2 meters in the negative direction. So again, here my displacement was -2, but I'm taking the absolute value of it. It paused again, and then I had a displacement. It went from 0 to 4. So it moved 4 meters in the positive direction. That was a displacement of 4. So I add all of those up, and I get a total distance moved of 9 meters. Okay, now let's look at the average velocity. So velocity is the total displacement divided by the elapsed time. It was displaced -1 meters. Oh, look, do we know the elapsed time? That's a little bit harder with the motion map. That's not too hard, but let's look at this. Remember, when you're looking at a motion map, the first dot, this is time 0. And then I've got time 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So here we have 11 seconds worth of data shown because we have 12 position dots. But the first dot is time 0. So this was -1 meters in 11 seconds. And gosh, I don't have a calculator, girls, but if we did that math, that would be the average velocity. Okay, and then the speed would be the distance that the object moved divided by that elapsed time. And so it moved 9 meters in those 11 seconds. Notice here that the average velocity is negative, because remember, the velocity is a vector quantity. It tells us not only how fast it was moving, but in what direction. And our object, by the end of this trip, had moved in the negative direction, right, by 1 meter. So its average velocity is negative. But the speed here is positive, because speed is always positive.